In this analysis, we will understand the reflection, echoes. Before that, what is understanding of physics in the speed of sound? Since sound is a mechanical waves, as you know, definitely the medium is necessary for the propagation of these waves. And the waves propagate by the compression, rarification simultaneously with the regular interval of phase if the medium density is constant. Such as, if this is a source is producing a sound wave of frequency f, wavelength lambda, and propagating with velocity v in a medium. This is the medium we are considering as a rare medium. And when it's coming to the other medium, which is denser medium, then definitely the reflection occurs from the boundaries of this medium if we think the propagation is uniform in nature. Otherwise, it will be reflected from a point of reflection where phase can be changed at 180 angles. These are 2 points, makes 2 different questions in IT. So I am considering this waves is coming from the boundaries of the medium as like this, and this yellow line showing you the reflecting waves. And they make superimposed on different points, they can make different things. But before that, we should know who are the rare medium for sound and who are the denser medium for the sound. The understanding of the medium depends on the speed value. That's why from the laws of speed of sound, we get the speed of sound is directly proportional to the under root of elasticity of the medium and inversely proportional to the density of the medium, which is known as mean density. If the medium is homogeneous in nature, you know homogeneity, then speed of sound we can write as under root of elasticity by density of the medium. And in such a situation, we can take different types of elasticity for different mediums as well as for different dimensions in the same mediums. Such as we know that elasticity of the solid is greater than elasticity of the liquid is greater than elasticity in gas. So definitely speed of sound in solid will be greater than speed of sound in liquid is greater than speed of sound in gas. Therefore, gas will act as a denser medium and solid will act as a rare medium, because the speed less implies that can be used as a reflector. That's why whenever sound is produced by a string or by a solid medium or by a liquid medium or coming to the gaseous medium, gas reflects the sound and give you the superpositions as we discussed in the open and closed organ pipes. This elasticity module can change with different dimension analysis, such as if you take a solid medium as a string, a solid medium as a railway bar, okay, or a solid medium of anisotropic compound, what will happen in the speed? What is the speed of sound in gas? As example, if we go in a iron bar, you get speed of sound is near about 1200 km per second. Since the speed of sound in solid is greater than speed of sound in liquid, is greater than speed of sound in gas. As we take example, in an iron bar it is becoming 5500 meter per second. In a water, its uniform density is 1200 meter per second, and in air medium it's near about 340 meter per second at NTP. So definitely the gas will behave as a rare medium, is it? Gas will behave as a denser medium because when the speed is less, definitely it acts as a reflector, and the solid will behave as a rare medium. So string wave, when it passes through the particular air medium, is reflecting back in your guitars. But this part of physics usually used for the variation to understand the sonar, echoes and different types of vibrating reflector. Similarly, we can also discuss the variations, such as what will be the function variability of temperature in the speed of sound, function variability of the pressure in the speed of sound, or humidity in the speed of sound, different types of analysis of it. In the solid, as we know, the elasticity for one-dimensional wire is written as Young modulus. So definitely we can write down the speed of sound in solid is Young modulus upon density, and this Young modulus already you know we write down that T L by A delta L, and rho is there, and as you know A delta L into rho can be written as effective masses, so that's become T L upon effective mass, and effective tension by effective mass can be written as effective acceleration. So effective acceleration into OL will give you the speed of sound in solid. This modified law usually used also in the long string vibration. Implies if you take very long string and if you like to understand the speed at different point, you can use this law for the different variations length of it. And such question usually you will get in your PMT paper, because this is not so hard part of it. If this is not, if the solid is not in one dimensional shape, if it is in three-dimensional shape, definitely you have to use the modulus of rigidity instead of Young modulus. So that formula also can be written as under root of modulus of rigidity upon density. As you know, the modulus of rigidity is pressure per unit twist. So this formula also can be written as P upon theta delta rho as the speed of sound. Although this type of question used to come in IIT sometimes, but you must know the law. In the question part, we will modify this law in a different manner. But in case of liquid, when you process, we know the liquid has bulk modulus as elasticity. So this elasticity module for the liquid will write as this: speed of sound in liquid will be under root of bulk modulus by density, and bulk modulus you know that is delta P by, which is come exactly basically P, delta P upon delta V by V is known as bulk modulus, that upon density. So whenever you go through it in liquid, you get a particular constant value for homogeneous liquid. Which is most important for your syllabus is the speed of sound in gas. But don't ignore the speed of sound in liquid, because you have fluid dynamics. Sometime in IIT, we modified that question with speed of sound with respect to the modulus variability in the liquid, when the liquid is dimensionally moving in different ways. Such as if a sound detector passes through different tunnel, when the petroleums are passing, one tunnel is providing the diesel, other tunnel is providing the petrol, and if we like to get the speed analysis in the higher physics to understand the molecular vibrability and the impurities we'll use in higher physics, at that case we have to exchange both the law together. That's why in IIT entrance examination, some question on the view of that point we used to put conjugate of these two chapters. Now I am coming to the speed of sound in gaseous medium. As Newton, what he understands that when sound wave passes through a medium in gas, the compression and rarefication comes together in different time interval for same wavelength of sound as a isothermal process. Implies, as per Newton, the speed of sound through the gas is an isothermal process of energy transmission. That's why he take this bulk modulus for the gases as an isothermal elasticity. And the formula for the gaseous module for Newton's law is like this.